Okay, so today we're going to talk about and introduce you to SQL. SQL, like we talked about in the pre-class video, it's a language for working with data. And it's just like Java and other things that can run on other platforms. So there are a lot of different SQL tools out there. There's a few desktop ones that are really good. And you'll use a few of those when you work with the a web backend. One of those is MySQL Workbench. But in order to avoid all the hassle of getting that installed right now, because we don't really care about that at this point, we're going to focus on just using free online tools that do the same thing. Since it's just a language, it'll just interpret it. This one's cool because it hides a lot of the complication it'll just automatically create a database for you. So you just create a database and then you can work with it. So that's what we're going to go ahead and do right now. Let me just check one thing. So our database is we're going to build together a simple database for the Star Wars API. So we'll grab people, planets, and species. We'll store data with that, and then we'll work with that data, of course. One thing about SQL is that there are different versions of SQL. You can see there's MySQL. You can see there's Postgres SQL. And there's SQLite. We'll be using SQLite because that's what's used in Android. And they're just variants. The major difference between them is the types of data that they support. So we look that up. Now we could even just do Android specifically. Yeah, that's a decent resource. So talks about some benefits of SQLite, and here are the types. In other SQL databases, you get a lot more types, whereas SQLite in Android really only has a few. You have integer, so this is any number that's not a floating point number. Real, which are all your floating point numbers. So this would include your int and your long. This would include your floats and your doubles. This would default to a long. So this is effectively a long because it can store that much data. This is effectively a double because it defaults to double precision. Text is any string. Blob is a binary blob of data. So a byte array could be a blob. And then null. So you can store null there. We're going to be focusing on these three mostly. We're not going to do much with the binary blob of data because typically we would use files to store that. So I could just store that in a file and then store a text path to it, which would be a good place to store that. The more data that's stored in your SQL database, the slower it gets. So if I store a big binary blob of data, that could potentially slow my database down significantly. So if I store just a string path to it, it will help speed it up and help with memory issues. We're also going to work with some breakout groups a little bit today. So the first thing we're going to do is we will build together. Let's see, which one did I pick? Okay. So together we're going to build a schema for a planet. For now, we're going to ignore anything that refers to another object. So the films refers to the film object. Residents will refer to the people object. And then we can ignore created and edited. For URL, we're just going to store the ID because that's what we care about. And then we'll store some of this other data. So what we can do is we can just copy this and bring it over here as a reference. This is going to have to be light because it's actually, no, that turns out, well, let's see. The JSON looks good. Let's see how well that is. So in order to create a table, and that's part of creating a schema. When you create a table, this is unlike JSON, whereas JSON is just a a blob of data. The only thing you need is you have to have a key and you have to have a value. And then there are specific types that you have to do. And there's a little bit of structure to the way the language is put together. Where with SQL, when I define a table, it defines how the stuff is stored. So you can go ahead and follow along with this part. So we go create table. SQL commands do not have to be capitalized. So if I just type create table, you can see it recognizes those. But best practice has you capitalize any SQL keywords to make it flow better and make it easier to understand and see that. So create table, and we'll call this planet. Actually, we'll call it planets. And then we're going to use parentheses and a semicolon. So this is a SQL. Let me zoom in on that. This is an SQL statement, or another word for an SQL statement is a query. It took me a little bit while to kind of make that click of a query is any statement in SQL, not just something you want to request back. So you're not, a query doesn't just mean that you're asking for something. A query in SQL is any statement that's executed. So this is a statement, which is a query. So we're going to, from now on, call any statement queries. So now we want to grab the fields that we want. So the first one we're going to need is ID. And this is going to be an integer. So we're going to capitalize that. The next thing we want to put are the name. And this will be text. Then we'll put the rotation period. And with SQL, like with everything else, you want to make sure that your naming conventions are uniform. So in this case, I'm using underscores instead of camel case. So I always have to use underscores. I should never use camel case. You'll see a little mixture of both. You'll see some people use underscores, some people use camel case. And it's really just up to the developer. But you want to make sure, as with anything, it's consistency. So with your code formatting, with your naming conventions, you all want that to be consistent. And same thing with capitalization. Any SQL keywords I'm capitalizing, that's part of the convention. Orbital period. And this can be integer. Diameter. You notice just like JavaScript or just like JSON, this is being, each line is separated by a comma. In other forms of SQL, instead of text, you have char and varchar. And that's basically an array of characters. So you have to tell it the maximum value that you can store. Whereas SQLite, it's a lot simpler. You just call it text. And this is going to be text. Terrain, it's going to be text. And you can see here we're storing these as integers rather than strings. So we can just see the difference there. Surface. I have no clue what this means. What an 8 in surface water means. That's interesting. Population. Integer. And then we're ignoring residence for now, films for now, created and edited we're already ignoring, and then URL is going to be the ID. So this is your basic schema. There's one thing that we're missing. With SQL, we define things called IDs. And an ID is a key. What a key is it allows SQL to index on this value. When we get into querying data in a few minutes, we'll see that you can query it based on anything. But if you query it based on ID, it's already indexed by that, so it's going to be much faster. It's like looking something up in the dictionary. If I look something up from the dictionary by the first letter, it's going to be much faster than if I try and look it up by the last letter or by the definition. you can theoretically read through an entire dictionary and find the definition. Or if the dictionary has synonyms, find the synonyms, and you could do that. But if you look it up by the first few letters, that's going to be the fastest way, and that's kind of what the ID is. So what we do here is we're going to mark that as a primary key. So this says, I want you to index it based on this. So this is creating a schema. You notice we have to say create table because SQL is a series of tables. That's the best way to kind of imagine that and picture it. And then each element is a row in that table. So here we give the table a name, then we're adding each of the fields, and we add the fields based on these values. So what I want you to do now, I'm going to break you up into, I've done this before. There we go, breakout rooms. We're going to automatically do that into 2 rooms. So you have 2 rooms of 4. So we just got to hope that Charles and Patrick are in different rooms. So what you're going to do is room 1, if you get assigned to room 1, you're going to do a schema for people. And room 2 is going to do a schema for species. Remember, we are still ignoring these lists. So anything that references another object, whether it be people or films, as well as this, you'll just get your key from here. So you'll just create a schema. We'll give you a few minutes, and then we'll come back to that. When we, just since this is the first time where we're using breakout rooms, I'll click to close the rooms, and then they'll close in a minute. So you can stay in your room, continue working. You'll just have a countdown for the rest of the time that you have left. So let's give this a shot. I will see you in, we'll set, I think 5 minutes is good. So we'll start with that, and then we might adjust that. Okay, so you'll see an invitation in a minute. Just click to join the room. Oh, just 1 second. I'm going to exchange. There we go. Go for it.
say what mine is, and then we can just see if they're all the same.
Yep.
All right, so I have ID integer, primary key, name text, height text, mass integer, hair color
The other group is going to be joining us in a few seconds. Okay, so just make sure you pick somebody from your group. Awesome. And just post your schema. One thing you can do is in Slack, you can click the plus and click code or text snippet. And then you can just paste that as code. You can even select the type. SQL is a type. Or to automatically select that for you. So what we're going to do is we're going to take those schemas and we're going to put them into our joined table so everyone has the same schemas. Sweet. So let's check this out. Looks like we have group 2 up there first. So let's grab that and check it. Seems like everyone was doing all right with that. So yep, ID integer primary key, name text, classification, designation. Yep, that looks great. One thing you'll see sometimes, this is great. Sometimes you will see, and I didn't do that, so I'm not expecting you to have done that. Sometimes you'll see a key be something like this, planets ID. Some database administrators like to have that specification there. It does make joining tables slightly easier, but it's just you type a little bit here to avoid typing a little bit somewhere else. So let's just grab the next one. I'm going to delete this because we no longer need that. So here we have create table people. Yes, I will post planets too. I guess if I ask you to do it, I should do it too. Okay, there you go. So now everybody has all 3 there. And that one looks good too. I think birth year, right, was some weird. Yep, 19 BBY. We need to have some Star Wars fan teach us how that works. I like this one because it's a very simple API. I love this window here. I just find it might be a bit too much Star Wars. But I guess some of you would disagree. Okay, so here are our schemas. Now we have 3 tables. When we insert data, we can now declare which table we're inserting, which data we're adding which table we are adding data to. So I want to just jump back into here and just do a couple of polls here. So the first one is, how do you feel about understanding what an SQL database is? And if you have any questions, throw those up in the questions section. And the next one will ask you how you feel about defining an SQL schema. Okay, and then we'll just do the next one. How do you feel about defining an SQL schema? Okay, that's good. There are other things to SQL schemas that we haven't gotten into yet. This is all we need for basic stuff. And then I think we'll have time at the end to get into relationships. And that's where the true power of SQL lies. And we'll show that. Okay. So now we're going to continue and we're going to start adding data to our tables. So this tool right here, you'll see you have a schema side and a query side. They're both queries. The only difference is with this specific tool, because it runs against a temporary database, each time you run the code on this side, it will populate the database. And each time you run the code on this side, it'll run that against a populated database. So we keep all of our creation and insertion SQL over here to allow us to quickly populate a database without having to retype it all. In a real database and in a real database tool, you only need to do that once or each time you add data. So I want to clarify that there's no difference between a query that's on this side, so a schema query versus a query over here. The only difference for this tool is it'll just populate it for us, help us manage that a bit easier. So what we're going to do is right underneath planets, I'm going to start populating planet data. So we'll create two insertion commands together, and then we'll go back into our breakout groups, and we'll have you, the way I recommend doing it is work on one together, build one together, and then have each person start populating a bunch of data. And then when I do the countdown time, just everybody share their stuff between each other, and then you can get it all together. The idea is we want to get a decent set of data, and we'll just utilize our manpower to do that. So I'm going to go into planets. Now, one thing that you can do in this database is if I query it without that, I can get just a list of all of them. There's 61. There's no way we're going to get all of them, but we will just grab what we can. So I'm going to grab 2 for now. And then while you guys are working on adding yours, I will also work on adding more planets. So here are our planets. You don't need to worry about copying that in. This is just as we've done before, just kind of to help us see. So our command to insert data make sure I get this right, so I'm just double checking. Let's insert into. Yeah, there we go. So you have insert into. Then you give it the table we want to insert into. We want to work on planets. Planets. And then you're going to use parentheses. So what we're going to do here is we're declaring the fields in which we're inserting data. We won't be adding a type. We're just going to be putting them all right here. So we have an integer, or sorry, an ID. One thing to know about the ID is when you mark it as a primary key, you don't have to insert it. What a primary key does is it ensures that it's indexed by that value, but it also ensures that each field has a primary key value. It will always have that value. So if I don't give it a value, what it does is it'll automatically increment. It will grab the last value that was created and just increment that. So the first one you insert will be 1. Then if you insert the next one, it'll be 2. However, due to the fact that we want to reference the Star Wars API, and this is generally what you will be doing, is you won't be creating a database and populating it in your code. Most likely is you'll create a database and then use either user-entered data or data from an API to populate that progressively. So we're not going to start with a huge populated database. We'll just increment that as we go. So you can just allow SQL to add those IDs. The difference is if you want to make sure that ID matches whatever the API ID is. So in our case, we already have IDs, so we'll just use those ones. So next one is going to be the name. Then we have rotation period. We have orbital period. We have diameter. We have climate. And I probably picked too many fields, but that's fine. We have gravity, terrain, surface, water, and population. Okay, so these are the fields that we want to add. The next thing that we're going to do is we're going to add this other keyword called values. So first we say, okay, these are the fields that I'm going to work with. And now we're providing the values for each of those fields. We want to make sure that the order matches. So we have 2, and then quote Alder on. Then we have 24, 364, that needs to be a quote. 1 standard. This one's a bit longer. I just want to grab that. Surface water is 40. Population. I don't want to count how many zeros are there. We skipped these 2, and that should be it. And we had a semicolon at the end. Sometimes you'll see SQL queries that don't have semicolons. It's because you can execute a query that's only one statement. But if you have multiple queries you want to execute, then you have to have semicolons between each of them. So now I can get rid of this one. And then the next thing we'll do is I'm just going to copy this. And you'll end up doing this a good amount of time in SQL. In code, we can just generate it. And we'll just add our fields here. The ID is 3. Rotation period 24. It's interesting how many planets have just a standard day. Except the orbital period is insane. What a coincidence. One thing I found, in most tools, if you click, you can set your cursor. If you double click, it'll select a word. And you double click and hold, you can just select groups of words. And I find that a lot faster. That's one standard. That's the same. One standard gravity. Sci-fi is really cool when they step away from Earth norms. But it makes it much harder to do that in film or TV, to step away from that. That's why books like, I guess Dune was really great, because the whole planet, you start out with the premise that the whole planet's a desert, and then from there you build everything upon that, which is really cool. There's another one I was thinking. Okay, so now we have our 2 insert commands. What I'm going to do, there we go. I was like, where did all my stuff go? So what I can do is I'm going to click save. So what dbfiddle allows me to do is now I have a version of my database, and then this index will version it. So these are kind of like commits. So we can grab that. You can also see run. So now this tells me that my queries, all the queries that we put together, are successful. We're not going to see, we don't see any results yet. We'll see those when we get into them. Oh, there we go. That's what I want to maximize that. That's going to be so much easier. Okay, so now we're going to do another set of breakout rooms. Let's do 5 minutes again. I would do more, but I don't want you all to get bored by entering a lot of data. So again, what I recommend is working together to write one insert and then make sure everyone has that in there correctly. And then from there, you can manage as a team. You work together to insert as many as possible. So I'm going to open all the rooms at 44. 44 after, we'll join back in. Okay, so I will see you in a few minutes. Okay, how did that all go? Feeling all right about that? I'm just going to grab all of these. A couple things I want to point out while I was adding mine. Let me just add this all here. There we go. One of these was Hoth, and you notice that. Where was it? Where was it? Oh, population was unknown. You might have run into something like this, where a field that we thought was an integer value was previously an integer value and would make sense as an integer value. They decided to put a string value in one of those. So at that point, we have to determine a value for us. So what I did is I put a negative value for population. Just like we use a negative value sometimes with unknown fields or invalid fields. That's kind of a standard you see. So if the population is unknown, I put a negative value. You'll also see that Dagobah, for some reason, I don't know how, but the gravity is not applicable. Maybe somebody that knows no more about Star Wars would know why. So it's the same thing. So we used, and then also Cloud City or Bespin has has two types of gravity. So one at surface, 1.5 at surface, and then one in Cloud City. So you can see that as well. It'd be interesting to do the math to calculate. So this is a massive planet, but it is a gas giant. So to somehow calculate the mass of this planet and see if that is a valid, I guess surface could be anywhere. So what I want to do before we start inserting yours, so hopefully you have somebody that you so hopefully you have somebody that you've picked. Oh, there's one more thing I wanted to show you. So with statements in SQL, just like in code or in Java and others, everything is for Python, nearly everything. I could add white space, so I could add a return here, and it helps line things up and make it a little bit cleaner to be able to see. And I should have showed you that beforehand. I noticed a few of you listed homeworld as an integer, or a few of the other ones. That's fine. We're going to get to that later, so that's fine. So just make sure either one person has all of them, or whatever we can do to get all of those, and we'll paste those all so we can all have this data set here. We're going to have I'm going to run this to make sure at least the stuff that I've written works. It's running query. Okay, query was successful. If I have something wrong, like if I put something there, we should see query execution failed, see results pane. So if you come down here, it says no such table, pull Dantits, whatever. So that failed for that reason. If I were to duplicate an ID, it may also fail. So let's see. There you go. SQLite constraint, unique constraint failed planets ID. So because this is a primary key comes with a few things called constraints. You can set constraints to any of these fields. So one of those is not null, so it can't be null. Another one is unique, meaning it has to be a unique value. No other value can be the same. And then another one is auto increment. So primary key has all three of those. So because I set Yavin 4's ID to 2 when Alderaan already had 2, it failed to insert. So if I just set that back to 3, it'll run. So let's go ahead and we will give you, that's 3 minutes, all right. So we'll do a 3-minute timer. And we can do 5. We're doing at a good pace. So here's a 5-minute timer. So I'll see you all back in 5 minutes. Please have somebody post all your stuff in Slack so we can get that up there. am muted still. Anyway, we just pasted all this stuff in. We'll have to see how the single quote handles it. We were able to compile and it ran just fine. We'll just have to see what's when we query it, if that'll do that there. You guys got a lot of characters in there. That's great. Okay, there we go. Query executed successfully. So now we have now inserted a bunch of data into our table. Let's just jump in. I have another query or another poll for you. One thing that I really dislike about Windows is if you wiggle a window, if I grab a window and I just shake it, it'll minimize all of my windows. And I don't think I've ever meant to do that when it's done that. Okay, here we go. So the next one is, I can assign a value there. So that you can, how do you feel about adding data to the database? I do see we have a question, so we'll jump on that as soon as we get to here. Windows key down arrow will minimize whatever window you're on. Yeah, that's true. I love the Windows key arrows, snapping things to half windows, and especially in Windows 10 has gotten better at that. You can snap to corners. That's one feature that I can't handle Mac. That's one reason why I can't do that. It always baffles me that there's so many people that, at least the people that I see sharing their screens on Mac, that don't have their windows maximized, and it's just, it always bothers me. Okay, so let's check out our question. We already, I think, showed this one. So what happens when you give an ID that's already used? Does it overwrite or reassign? Well, we did see that. It actually fails. So it won't let you do that, and it'll fail that query. So good. I'm glad we were able to get that. So now the next thing we're going to do, now we've added data to our table, to our database. I'm going to update this. So now we have version 1. And now we're going to create a query. So the thing that's awesome about SQL. So if we looked at Firebase, when we did our Firebase with JSON, it was dumb. It's a dumb database because granted, there's a ton of Firebase that we haven't touched on and we won't touch on. We just really wanted to use it so we can put, post, and delete and get. So if you're interested in that, you can experiment with that. There's a lot of cool stuff you can do with Firebase. But when I query it, it gives me, if whatever endpoint that it did, it gives me everything at that endpoint and below. Everything. So if I queried for a list of entries, it gave me all of the entries and all the data for all the entries. With SQL, it allows you to do something really awesome. And that's tailor a query. So let's check this out. So first we're going to go for a basic query. We're going to try and list all, remember we talked about CRUD-L? We didn't really touch on that we did the pre-class, we didn't talk about it now. So this is where we're going to start getting into some of those. So our create, we already did create. So this is create table and insert into. That allows us to create fields. So create table, it creates a schema, and this will add stuff to that schema. The next thing we're going to do is now we're going to read values. So reading values does you do a lot of cool things, but the first one we're going to do very basic. We're going to do select, and we can maximize this. Actually, we don't want to maximize it because we want to see the results down here. Select star. What that means is that we'll select all of the data, all of the columns or all the fields in that data, and return that all to us. And we'll do planets. Oh, and we're missing one thing. From. The cool thing about SQL is it kind of flows like a language does a little bit. So I'm going to select everything from the table planets. So if I run that, now you can see it's now selected all of my tables. So Alderan, Yavin 4, it grabs them all. It has all these fields, so it returns them to us in a version that we can get to. Yes, I need to post my inserts. You are right. I said I was going to, and I just haven't yet. So let's grab that. Okay, there you go. So now let's try that with another one. We call the next one species. So if I run that, there we go, Yoda species. So it actually handles the single quotes really well. I've never worked with that. So glad to see that. So let's make sure it gave us all the species we have inserted. 1, 2, 3. Awesome. So we got all 3 species there. And you can see it lists their IDs and all of this other stuff. Like how Yoda's species is just Yoda's species. I'm assuming he's just so old he outlived all the rest of his species. I bet there's an interesting book on that. And let's just, lastly, we'll do people. So if I run this, it now lists all of our people. Interesting. So they put unknown for a lot of these. Seems like you guys got a good amount of them. Awesome. So now we can do just a list of all the stuff. But remember what we talked about way back. Sometimes I don't want all of this stuff. Sometimes I just want a simple list of ID and some basic information. So like an ID and a name. That way I can see it's the name of the person. It's kind of like with a list detail view. I don't want to get all the stuff when I'm looking at all the lists because I'm going to look at everybody. I want to get a couple of fields and a way to get more. So in SQL, the way to get more is going to be with the ID. Or the best way to get more, I should say. You can get more with any of these. And we'll look at that in the next one. In the next kind of section. So now what I want to do is I want to grab people. But all I want is I want the ID and the name. So what I can do is I can say ID, comma, name. And when I run this, it now will list all of my people, their ID, and their name. That's awesome. I can do that with any field. I don't even have to grab the ID. I could grab, and it doesn't even have to be in an order. So I run this, it'll give me their height and their name. So SQL allows you a lot of flexibility in what you grab, and in the back end, it handles that for you. So because they all have ID and name, I could just do that from everything. There you go, your ID and your name. So now you have all of those fields. Pretty awesome, right? So we're not going to do a breakout room right now, but I just want you all to write one query. I want you to get from our people table, I want you to get a person's name and birth year. Let's do ID, name, and birth year and return it. And we'll just give it 1 minute to do that. So what we're going to have you do is just paste that into Slido. That way it keeps it anonymous, so you don't have to worry if you're not 100% confident. Oh, I should probably make that live. There we go. Now it's live. So right here, I just pushed a poll. So I'll just grab one of these. I'll run that. There we go. ID, name, and birth year. I want to grab this other one. This other one doesn't have any spaces, so I want to see. Actually, no, it does. It's just not showing up in response there. Okay, there we go. Let's see. And there you go. So without spaces here, as long as you have the comma, it's fine. I'm pretty sure that, yeah, that will only work if you're separating things by commas there. For readability, I prefer to have spaces, but again, it's just consistency. Make sure you're consistent. Awesome. So now I have this list here. I want to get more information about Wicket, Sistri, Warwick. So I see that they have an ID of 30. So now, oh, actually, first let's do a poll. Let's make sure everyone's good with this so far. We're retrieving listed data. So how do you feel about retrieving listed data from the database? Not terribly difficult. Allows you to filter out stuff and show only the fields that you're interested in. Seems like we're doing all right there. Good. So the next thing we're going to do, and one thing about this tool I didn't clarify, update will run the stuff on this side and run will run the stuff on this side. So anytime that I want to update my database, let's say I want to add fields to it, or maybe I delete something and I want it to be put back in, I can just click update. So double checking on the recording. So now what we're going to do, let's go ahead and stop that. Now I want to get more information about Wicket here. So what I can do is I'm going to say select star because I want to get all the information. So let's say we have a list here, our recycler view. We click it, and when I click it, it's going to run this query. It runs this query, and then I'm going to go to the detail view and display it. So I want all of the details because I want to display them all. So I'm going to select everything from people. Now we have another clause called the where clause. I should clarify that each of these with this keyword is called a clause. So you have a select clause, a from clause, and a where clause. Here we have an insert into clause and a values clause. Insert into and values are really, really tightly bonded, so you're not going to see those separated, but these might be split up. When you're getting data, generally you're always going to have select from. It's the where that will change that up for you. So now what we're looking for is we want to get specific data. So what we can do is I want to get it by the ID, where ID and Wicket's ID is 30. And if I run that, now it'll give me all the information about Wicket. And then you can do that the same thing. The same thing that we were doing before with list, you can do with where. So I could just grab again his name and height. And if I run that, it'll give me just his name and height. So what the where does, so select will tell you what information to get. So which columns to grab from. The where clause will allow you to grab anything. It tells you which rows to grab. So select is which columns, where is which rows. So what if I want, let's just do name and ID again. I want to grab something else. I want to grab everything that has ID greater than 30. I can totally do that. So there you go. These are all greater than 30. What if I want to grab stuff if the ID is between, let's go 15 and 35. And there you go. Everything between 15 and 35. So there's a lot of stuff that you want to do. Right now we're kind of just making things up, but there may be situations. Let's say I want to page things. I only want to load the first 10 values from the database. You can do that with a between. And I should capitalize and here. That's kind of... There we go. That works. It's just not letting me grab the and. I think it's because I'm zoomed in. If I'm zoomed in too much, it's not going to... It thinks I'm clicking here. That window's a little bit bigger. So there's a lot of things that you can do. You can search on a string. So let's see. Name, like, Skywalker. Let's check this out. So you can see it's not giving us anything. It's trying to do an exact match. If I were to put this % symbol here, it should... There we go. Grabbed Luke. Grab everybody with the last name Skywalker. So this allows you to grab multiple pieces of data. You can filter. You can do a search. So if you want to add a search and allow the user to search your database, you can do that. And then you can make it be an exact search or a partial search. So if I were to just do %sky and query that, it'll search that for us. Something that has a capital S in it. And you notice that the capital doesn't matter because Owen Lars was grabbed and Luke Skywalker was grabbed. So it ignores capitalization. Lastly, the last thing that at least I listed in the slide, there's a lot of other things you can do. There's a lot of awesome resources on SQL. So if you want to learn some more advanced techniques, you're welcome to do that. None of that is something that we need. So I can also provide a list. Whoa, I didn't want that. ID in 0, 5, 10. And what it does is it looks for if anything is in that range or in this array that I have here. It'll check to see if that exists. And I just happened to grab Luke and Leia. That was random. So I specify multiple possible values to be able to filter on that. So there's a lot of cool stuff that you can do with SQL. And again, this is kind of just scratching the surface of SQL. And that's because on the Android side, you typically won't have a super advanced database. You'll generally just have a couple of basic tables and you might have a relationship or two. And we'll get into relationships in a little bit. But in the website is generally where you'll get more powerful databases. And when we get to that web portion, with John Mitchell, you'll go into more advanced SQL stuff. I don't want to overwhelm you, so we're going to go with basic stuff. My first SQL class, we spent the first half of the semester doing relational algebra. The way it was, you have these two tables. I want you to put together a relational algebraic equation to combine these two tables in this specific way. And that's what you get when you get into database administration. But we're not going to be DBAs. We're going to run a simple database in Android, and that's how we can do that. So I want to do another poll, see how everyone's doing on this, and we'll check for questions again. Yep, relational algebra. Brandon, dude, you're a major Star Wars nerd. Welcome to the club. That's one thing that I love about being a developer and being an engineer is, going to high school and growing up, you get all the cool jocks, you get, and I guess it was a sign of the times too, because it's much more okay to be a nerd and be into comic books and things like that now, especially now that Avengers has made $1.2 billion over the weekend. I think it's okay to be a nerd now. But being an engineer, you rub shoulders with a bunch of nerds, and it's great. We had a board game club at my last job where we got together every couple of weeks and played board games. You can't get much more nerdy than that. I guess the only way you can get more nerdy is if it was a D&D club. And the only reason we didn't do that is because D&D takes way too much time. Yeah, I think that's great. So I think as a combination of, society, being a nerd is cool now. And And also, being an engineer, you work with a bunch of nerds. And it was weird that somebody was into sports rather than video games. And that was hilarious. We had a couple of guys that just didn't like video games at all. And they were into sports. And they were the weird ones. And it was so glorious. Whereas, so my brother and I last September, we flew out to LA and went to an Overwatch World Cup series. So we went and watched video games, somebody else play video games live. So we flew out to actually see that. That's about as nerdy as you can get. We got back, we were hyped, so we started watching it. We went back to a family reunion, and I hooked my computer up to the TV, and we were watching it through Twitch, and everyone was just so frustrated with us. They wanted to watch football. And don't get it wrong, I like sports. I like playing sports. I have a hard time watching them unless there's a team that I'm really invested in. So if the A's are playing, and if the A's are doing really, really well, or if the 49ers or Kings are doing really well, that's awesome. I'll watch it. None of those teams are especially great, so it's not very often that happens. Back in the 2005, the early 2000s, when the Kings were awesome and they were like one of the best teams in the league, that was a highlight of my life. Just that period of everyone in the community coming together, that was really cool. But anyway, that's enough side tangent there. I should have actually posted this this poll before I went on my tangent. There we go. So how do you feel about filtering data from a database? So using the where clause. We can do some pretty cool stuff with that. And the next time we touch on SQL fundamentals, we get into more advanced stuff with the where clause. And that's great. So the next thing that we're going to do is we're going to, I will do that in a minute. Should we give you, we're not going to give you a challenge on this one. We could, but we'll just move on for now. So the next thing we're going to do in our list is removing data from the database. So now, let's actually bring up PowerPoint and I'll show it to you. So CRUD. Any functional database will be able to CRUD. And that's kind of the minimum requirements for it to be a database. So we can create. We used insert into to create. We used the select and where clause to read. We'll update data, but first we're going to delete data, and then we'll get back to updating data because delete's a bit easier. A delete clause is a very simple one. It's a combination of so instead of select, we're using delete. So I'll just replace this with delete. You still do from, you tell it which table to delete from, and then you use your where clause to select. This is going to be you want to be very, very careful with your where clause. One thing that I like to do, and one rule of thumb that you want to do, is always run a select before deleting. So I selected using this from and the combination of these from and where clauses, and this got me Luke and Leia. I know now that if I put a delete instead of a select, it will delete Luke and Leia. I want to ensure that because a delete is something you can't undo. So if I deleted my entire table, I can't undo that. Luckily here in this tool, you have the update. So I could just refresh this page and it will update it. And that's great. So if I run delete, so you can see that it didn't give me any results back. So now if I were to say select, select and run that, and now it doesn't give me anything. I need to select star. Well, that's not helpful. Let's do this. This could be part of the tool. So I'm just going to copy this and do delete, and then we'll do a select immediately. So you can run two queries just like over here. You can run multiple. Over here, you can run multiple. And it could be up to the tool. The tool might just run this each time I click run. So let's try that. There we go. Luke and Leia are gone. And then if I could just grab all of that, run that again. So now we no longer see 1 or 5. So delete will delete it. With this tool, it's going to rerun our stuff. So since we have all of our fields inserted here, we're safe. So if I were just to delete from, if I were to run this command, now I've wiped my entire people table. It is gone. Exactly. It's like deleting C Windows System 32. One thing that I did that was one of the worst nights of my coding career, and this wasn't even at work. I have a media server, and I wanted to copy files over from a Windows system to a Linux system because I was setting it up on Linux when before it had been running on Windows. So I took the hard drive, plugged it into Linux system, and I wanted to get rid of some of the top level Windows stuff that you get with a Windows hard drive. I accidentally deleted all the files on a 3 terabyte hard drive. That was pretty awful. And that's kind of along the same lines of you want to do a select before you delete. Luckily, I spent the next 4 days recovering and I got most of them, but they're still in kind of a weird state. So any of the Sesame Street TV episodes I had for the kids, some of them it thinks they're movies. I had to come up with some weird logic to try and figure that out with Python. But yeah, you want to make sure that you run a what was I going to say? You want to make sure you always run a select before you run a delete. That way, you run a select, like in our code, you would run a select. If I want to delete just one thing, I will do a select and I'll just make sure that I only got 1 row back. If I only got 1 row back, I'll go ahead and do a delete. Otherwise, I'm going to throw an exception or do something. And that logic really only matters when you're writing your code because you're going to really bolt down and limit what people can do. So my delete, I'll have a delete 1 or delete entry field. Maybe in this one, I'd have a delete person. And it would accept the person's ID and it would delete it. So when I'm developing it, I want to make sure that it's only going to delete one of them. After my development's done, when I push that to production, there's nothing that the user is going to be able to do to limit that. So that's fine. So you should really want to handle that properly. Yeah, I try and I found myself really wanting to get into some really expensive hobbies lately. So that could be, yeah. Sorry. Okay, so now we got the delete. So we feel pretty comfortable with delete. I'm not going to worry about doing a query on that one. We'll do that. We'll do it combined with update because update's where we get a bit more of the logic. So now, thanks to this one, I can still do select star from people. There we go. So it's now repopulated our database. So we're good there because we have all that right here. So the next thing we have, we're going to combine another set of clauses. We're going to learn 2 more clauses here. We're going to learn the update clause, if I can spell. And with the update clause, we tell it the database we want to update. So in this case, we'll use update people. And then this is a little bit different than insert. What I use is I use the set key. And I am just setting the values. So I want to set Leia Organa's name to Leia Skywalker. So I'm going to set name is equal to now with this one, you're going to need, if you look at this, if I run this, heck, let's run it. Select star from people. Everybody is now Leia Skywalker. So really want to be careful. This is another situation where we want to run a select before because we want to add our where clause. So anytime you're making a change to the database that would use a where clause, you want to test your where clause by using a select. So where name, I should be able to do name like. Leia. So now let's try that. Now if I run it, remember it's going to run this, then this. There we go. Now she's Leia Skywalker. So to update a field, you're going to run the update clause, tell it which table you want to update. Then you're going to set, and this is going to be the field you're going to change, where, and then you use any of our where clauses to select it. So now what we're going to do is we're going to give you another minute. I want you to update a field in any of the databases or any of the tables. So look at something and see if there's something. Brandon, you can fix their spelling. So anything that we want to update, we can go ahead and update. And then I'm going to put another poll out there so that you can do that. So go ahead, do that. We'll give you 1 minute to do that. And then I'll create a poll for that. Somebody's a big fan of Qui-Gon, huh? Wasn't that Liam Neeson's first action role? First time I saw him. Okay, we'll give it 10 or 15 more seconds. Luke Vader. Wasn't there... I remember my cousin, when I was like 10, told me he had read the... he blew my mind when he told me that there were 3 more episodes after the original trilogy in books. And he'd read that Luke turns evil and then comes back. So yeah, Luke Vader. I'm going to just grab one of these because this one looks kind of interesting. So, yeah, I'm pretty sure that was an actual book. But yeah, that was... that's something that blew my mind. So I thought when they did the new ones, they were going to do something like that. And then they killed... I guess I shouldn't say anything. The movie is a year old, but... And then that didn't become not the thing. I'm just upset that people are... I don't know if it's because I've already watched Avengers, but I find a lot more spoilers in my feed. There was a channel that was all spoilers for it. I'm like, come on, guys. And people will be like, spoiler, and then put the spoiler in the title. Like, that doesn't help, guys. Just say spoilers for Endgame and then put it there. And I watch Game of Thrones, and I'm not a huge... I like the story, but I'm 2 episodes behind now. And I hate that people are putting spoilers up. Just stop spoiling stuff. Just farming it for likes. Yeah. And now I'm 2 episodes of Game of Thrones behind, so... Luckily, there seems to be contradicting spoilers, so hopefully that helps clear it out. So let's check this out. So I just ran update people, set name not turkey. Oh, that was 2 updates. So we have 2 commands, and then you have your select there. So you just replaced everybody. Gotcha. So that's a good point. So there you go. You can use the not to run that. And there you go. Everybody, there's one person that's not turkey and everyone's turkey. So it's kind of like Duck, Duck, Goose. It's my daughter's favorite game. So not turkey, and just pick a random one. See, Jake, though, to be a fake spoiler, it has to be believable. So I'd have to say something that that doesn't happen in the thing, but is reasonable. I like to stay away from that. I learned my lesson with I had read Lord of the Rings, and right before the Two Towers came out, I told my friend, was it Two Towers or Return of the King? I think it was Two Towers, where Frodo and Sam meet Shelob. I'm like, oh, Frodo dies. No, he doesn't die, because I thought if I told him that he dies, but he really doesn't die, it would heighten his experience, right? And then I felt really bad, and I said, no, he doesn't die, so that kind of killed it. So I've decided to stay away. Yeah, not equals can be written as less than and greater, or whether less than greater than symbol. Yeah, exactly, if you think about it that way. Okay, so now we can see, now we have an update. Now we can do create, read, update, and delete. Let me do a poll on that to see everyone's fields. I just need to edit that. My grammar is not 100% good on this, 100% correct, as I'm justifying my poor grammar. I use poor grammar. So how are you feeling about removing and updating data? Yeah, there's our update. Yeah, there's our add. There's our update. There's our delete. I'm just checking to make sure I've covered everything so far. We talked about schemas. We talked about data types. We talked about field constraints. There's not null, there's unique, there's primary key and foreign key. So we can, any of these fields that we're adding here, just exit that, could be null. I could provide null there, and you can see it's highlighted. And it doesn't matter if it's capitalized or lowercase, it recognizes both. But in order to prevent that, I can just say not null, and that will allow it to not be null. So now if I try and put, if I cut that and do null, if I run that, it should throw me an error. There you go. Not null, constraint failed in the table parent field name. And there we go, that's fine. The next thing we're going to talk about, actually, let's give you all a break, and then we'll dive into relationships. This is something you don't need to worry about. I think it's a stretch goal for today's assignment, but it's really where SQL shines. So let's do another 5-minute timer, and we'll see you back. Let's do 3 minutes. I'll see you back in 3 minutes. Okay. So now we're going to talk about relationships. Apologize, I don't have a relationship diagram for our Star Wars API stuff. I might be able to create that for another time. But what we'll do is we'll work with this one I grabbed from visualparadigm.com. We also had the one that was in the pre-class videos. The class one. But I don't want to explain that again. I'd like you to see something new. So what we're going to work around, we're going to start dealing with relationships. So this is a stretch. It's not part of the basic of SQL, but it's very powerful and it's something you should be able to understand. So what this is you can see these lines here. These lines designate types of relationships. And we could go into what the symbols mean and all that stuff, but we won't worry about that now. But you can see each of these orange blocks is a table. So you have an author. He has a name, he has an address, and he has a URL. You have a book. A book actually has a relationship with an author. So the way they do that, and maybe this wasn't the best example to grab. We'll just do that with now. They will have a relationship with author, and you can see author name. So their key, this is interesting, I guess, to see this, is this key symbol tells us that it's a key. In SQL, you can have a primary and a secondary key. We won't worry about that. But a key can also be a string value. So this name is a key. So the author doesn't have an ID. They have their name as a key. That's not best practice. It's possible. So to show you that it is possible. So this book has this relationship. So what it does is it will store the author's name here, right in this field, and it'll link those two. Now when I look up a book, I will get the author's information. And you can see this arrow meaning that it's linking to that table. The publisher name is there as well. So it has a relationship with publisher. It also has a relationship with a warehouse. But you can see it's not storing anything here. This warehouse is storing the data. Let me jump into the PowerPoint one because that one's a better example, I think. So here we have a student. Let's start with a student. So a student has his ID, has his first name, his last name, and the ID for the group to which he belongs. You notice he doesn't have any grades. There are no references to his student's grades. So the way that this works is that a grade is a separate entity. It will hold a reference to the student's ID. So in order to view a student's grades, you need to join these tables. So what these are called foreign keys, meaning it's a value in my table that's a key in another table. So the student ID is a key for student. So my grade holds the student's key as a foreign key. So this can take a little bit to kind of wrap your head around. So there are different types of relationships. There is a one-to-many relationship. There is a many-to-many relationship. There's also one-to-one relationship, but you typically won't see that. A one-to-one relationship, you just combine the tables and it's done. So what a one-to-many relationship means is a student can have multiple grades, but a grade can only belong to one student. So when you start building a relationship, you want to define that relationship in your head. Okay, my student can have multiple grades. In SQL, there are no arrays. There are no lists. So this is how you can do that. So I'm going to have multiple grades, and they will each have my student's ID inside of them. So when I query it, I will query the student table, and I will combine that with the grades table. And what that does is that will return to me multiple rows for the same student, and each of those rows is a separate grade. So I can query all the grades. So let's say Bill has an ID of 1. I can query all of the grades that have the ID of 1 because that matches Bill's ID. And that will give me all of Bill's grades. So let's do that a little bit. We've actually, what was it? The species one? No, the people. Yeah. The people team already gave us a starting there. So this is homeworld. What this is, let me just maximize that and zoom in so we can see it a little bit better. Whoa, that was a bit much. There we go. We'll just do 300. That's just a wall of text. Just look at this. This homeworld is an integer value. The integer represents the ID of the planet to which the person belongs. In this situation, you have a one-to-many relationship. A person will only have one homeworld. But a homeworld, a planet, can be home to many, many people. So that's a one-to-many relationship. So now what I can do is I can say, okay, give me all of the people that have a homeworld of an ID, whatever. So let's see that. Now, our data pool is pretty limited here. We don't have all of the entries. We only have a few of them. So we'll see what we can do. Naboo, there's got to be a number of characters that have a homeworld of Naboo. And we'll just play around with these ones. So let's... Fine, I'll run, because that should... Of course it doesn't. Zoom out. There we go. That's what I'm looking for, those arrows. So now what I'm going to do is I'm going to say select star from people where home world is equal to, I think Naboo was 8, right? So let's run that. So there you go. R2D2's homeworld is 8. We can do 9. Okay, so we don't have any characters whose homeworld is, I think 9 was Coruscant. Let's just go back to R2D2 because we have this result. This is great, but it's not as helpful. So I can grab everybody that has that homeworld, and that's going to be multiple queries. So the next thing we can do is we can join these tables. So first, we really only touched on it, or we didn't spend a bunch of time on it. So I want to see if anyone has any questions on, where'd you go? A foreign key. One last thing is you can denote inside of your schema something that is a foreign key. What that does is that will guarantee, let's try that, foreign key. So if I run this, we'll actually have an error. Shoot, now I overstepped a little bit. Let's do a quick search. And then let's check our PowerPoint again. There's one key that I forgot. Okay, yep. There was a couple things that was missing there. Whoa, I didn't want that. So what we need to have is we say foreign key. This is a separate row. That's my issue. So I define my entire schema, and then I define the foreign key. So my foreign key is home world. And then I tell it references. And then I tell it which table it references. So it's going to reference planet ID. So now when I run this, there we go. So now it builds it up. It says, hey, this is a foreign key. Homeworld is a foreign key. And it references the ID field in the planet table. So that just kind of helps with a constraint. It is not necessary, because we'll get to that. So I want to see now, where did you... How are you feeling about what the role of a foreign key is? Again, this is something that has tons of depth, and I don't want to overwhelm you. So we don't dive super deep into it, but it is something fun, and we do have time to go over it. So as long as you're relatively all right, let's make sure we have any questions. Okay, we don't have any questions right now, so that's fine. So it seems like most of you are sitting pretty well on that. Good. So the next thing we can do, well, first, again, with a foreign key, you can have a field that's a foreign key that doesn't use the foreign key constraint. The foreign key constraint just does additional things in the back end for you. But as long as you have a field that references it. Typically, you would have a foreign key that is, you would specify that it's a planet ID. However, this also specifies it because it's saying a home world. Maybe you would just say home world ID because potentially you could have another field called, you could reference, that's the cool thing about, another cool thing about foreign keys. Maybe I could say, oh, there you go. No, that doesn't work. That gets into a many-to-many relationship. So let's say we have current planet ID. So now I can have another key that references planet, and this is going to be the current planet they're living on, or a destroyed planet ID. Maybe this person has destroyed a planet. If I spelled that right. So you can see how we can keep adding fields, and what that does is that adds data without duplicating data. Remember our single source of truth principle? This is even more important with SQL. You don't want to store data multiple times in your database. Not only does it take up more space, it also makes it so you'll potentially have two different conflicting pieces of data and you don't know which one is correct. And there's many other reasons why not to do that. So you want to be sure if you want to have, so if we had a home world ID and a current world ID, or maybe we have a list of planets this person has visited, we want to make sure those are all referencing the planets table. That way we can grab all that data as we want. So the next thing you need to do with foreign keys is to combine data between tables. So this uses a join keyword. So I say select star from planets. And then the next one is join. And you can also add a white space here to make it easier. So what I'm doing is I'm selecting the base value that I want. I want you to grab everything from planets. Then I want you to join. I want you to add people to that database or to that my results on. So now I want you to say, okay, now I have both of these tables. How do you want me to combine these entries? How do I say which one matches? I will say planets.id equals people.homeworld. So what this says is I want you to grab all of the planets and all of the people. I want you to grab all the planets, and then I want you to grab all of the people and combine them with my planet's results. And the way you combine it is you say, if planet ID is equal to homeworld ID, I want you to take both of those entries and combine them. So let's check this out. So you can see now we have a few issues here. Oh, homeworld underscore ID. My schema is bad. Let's run that again. Okay, so now you can see I have R2D2. There's the rotation period, the orbital period, the diameter, climate, gravity. Let me scroll through this. There we go. So I get all of these fields. And you notice it's not specifying which one is which. It just took those entries and combined them. And you notice it's only returning results where the person has a home world that we've added. So now another thing you can do, let me just copy this and throw that in Slack, and then we will, because I want to save that. I want to swap these. People, planets. What happens if we swap it? Now what you see is you see the same thing, it just flipped the data. So it's only still only going to return stuff that's there. So you have Naboo has a person, Alderaan has a person, and Endor has a person. Now there are different types of join that we'll get into later. There's a left join, there's a right join. And what the different types of join do is it will return results differently. So for example, a left join will say it'll return all of the planets, even if they don't have people that are in them. But we get into that and we'll dive into that later as we get more stuff onto that. So this is going to be your basic join, but that's not super helpful. So let's say I want to select ID and name. So what happens if I do that? And then I run it. You can see there is an issue here. We have an ambiguous column name ID. And in fact, the name is ambiguous as well. What we need to do with join is we need to specify the names of the columns that we're working with. If we looked at, actually, we might be able to see that. If I just do star again, let's check our results. There's a name, there's an ID. You see, we don't have the planet name or the planet ID. That's because they have overwritten themselves in our result. So I'm only getting my person's ID. So you see Leia Organa, we knew she was 5 from before, and Wicket is 30. So what we want to do is we need to say select planets.id, planets.name, people.id, people.name. So you specify that way using the dot operator. Now when we run that, we still see that we only have ID. We have selected both of these fields, but again, they have overwritten themselves. So the last thing we need to do is we need to add, and this is where, if we jump back into, or if we look at the PowerPoint one, let me just bring that up again. This is a benefit of having student ID, grade ID, because then it won't, when you join them, they won't overwrite it. But that's okay, because what we can do is we can say as planet underscore ID, planet name as planet underscore name. So with as, I think I spelled that wrong, but I can't even see. There we go. So what the as keyword does is it will, come on, just let me, there we go. What the as keyword does is it will temporarily rename a column in your results. So now I have planet ID, planet name. Let's run that so we can actually see my correct spelling. And then you have the regular name. So this will now allow us to grab any number of columns that we want and then rename them. So that's what you get with a join. It allows you to combine data from multiple tables. I may have another example here to show you. We probably saw that in the pre-class video, but we can look at this again. This is, you can see this is the students one that we looked at before, and you can see how you can chain multiple joins together. So what this is doing, this is grabbing students, grades, subjects, and teachers. And it's going to return to us. And you can see doing these joins takes a lot of calculation time. it should return to us the student's first name, last name, the grade they received, in which subject, and which teacher. We'll see if that finishes. We'll get back to that later. So another type of join that we haven't talked about, or another type of relationship, is a many-to-many relationship. So this is a one-to-many, meaning that each person has a single homeworld, that's the one, and then each planet can have multiple people. So that's your many part. So what a many-to-many relationship is it is we could also join on species too, but we won't worry about that at this point. A many-to-many relationship is this films. So if I go to people, let's grab somebody that's been in most of the films. So you can see a film will contain multiple characters, but only a film can contain multiple characters, and a character can belong in multiple films. But remember, we can't store lists. So how do we do that? We can't have multiple IDs in each one. So the way that you do that is using a relationship table. Grab that. I will show that to you, and then we're going to be done. So you can see here we have something here. This is a joining table. What this does, you can see it's just IDs. So what you can do is I can take the subject, the teacher, and the group. And this will allow me to join all three of those. So this is just a table that lists all of the relationships between these things. So a teacher can teach multiple subjects. They can also even teach the same subject to multiple groups. So what you do is if a teacher 0 teaches subject 1 to group 5, this would just be 1, 0, 5. If they teach subject 1 to group 6, it would be 1, 0, 6. And that's the entry there. So the way that you join this, and our Star Wars doesn't have the example, so we can just look at this one here. It's still, wow, that's still running. It's probably just not liking it. Is you have this relationship here, and you join it like you would on any table. Each time you join something, you add more fields that you have to work with. So once I add the subject teacher table, then I can add the teacher table based on the subject teacher ID. And again, this gets to about as far as we would ever get with this. This isn't going to be part of your assignment or any of the sprint challenges, but it is something that is interesting. So if you want to learn more about SQL, W3 Schools is a great resource for a lot of code. I noticed that Basil asked about a resource for SQL syntax validation. There are a few. You can just do a search on that. There's nothing that I really love. One thing that a lot of them will do is give you something like this, where you'll build a database and then you will test queries against that database. And that's going to be the closest you get to syntax validation. Just because you have all of that stuff. So that's where we're at for today. Let's show you, we just hit 12 o'clock. So let me just quickly show you your assignment. You're going to be using dbfiddle to create a database. I really hope I forgot to check if we used Star Wars for this one. Okay, cool. So what you're going to do is you're going to use add 2 text files to this database, or not this database, this Git repo, and then you're going to give us your code. So you're going to put in one file will be the left panel, and that left panel, remember, is going to be creating and adding data to your database, and then your right panel will just be each of your queries. So you just have a table for your schema and all of your data, and then you have a table for your queries that you're running each against. And you just go through and put everything together. It looks like you're picking, and then you have joining tables at the end. You're going to be picking your own database. So you can pick anything you want as long as it has data that you can work with, and you can just build the database from that. It's not too bad. It's just kind of repeating what we've done today and just getting that into your head. So tomorrow, now that we know kind of SQL, tomorrow we're going to have a lot of code. It's going to be a big code day because SQL and Android takes a good amount of code, and we're putting that together. So let me just check to see if we have any questions before we go. I guess we do have one last poll. How do you feel about combining data from multiple tables into a single result? And it's all right. I don't expect you to be able to do a many-to-many relationship. I would be blown away if you were able to do that. I'd be impressed if you can do joins like this, and that's great. So having this be mostly agree is going to be awesome. Let me just do a quick check. We don't have any other questions. That's awesome. So let's wrap this up. So remember, DB Fiddle is the tool that I like to use. Is if there's another one that you would prefer to use, that's fine. If you have something installed on your computer, it might run a bit better. But you just have to be comfortable with working with that. You just got to make sure one file is going to have your schema and your data, and the other file is going to have each of the queries that you're running. So we can check that. Looks like Patrick asks something else. We have one more that. So Patrick's asking about Android brown bags. We have one more that we're working on scheduling, and then we have another one. If you might have noticed, I added Justin to our channel. He was hired to work with mostly with the engineering team, but he has a bunch of experience in Android. So he's going to jump in for a few weeks and help us out developing the curriculum. I talked to him about potentially doing a brown bag on something interesting. He's worked with a lot of other libraries like Dagger, which is a really popular one. RX Java, which is a popular one that works with retrofit, and a few other ones that we might have him jump in and do a brown bag on. And then he may teach a lesson next week, depending on how comfortable he feels. He has a lot of experience with testing, unit tests, and UI tests, and all that stuff. So he might dive in and work and do a guided project with us on that one. So we'll just see how that goes. But that's kind of what we're looking at in the future. As far as that goes, we don't have any other ones scheduled for now. Yeah, we'll see about what we can do with that. I think that could be great. RX Java is a great tool. There are a lot of good libraries out there. One with this one, actually Charles will know about this one. Charles worked with Room, which is a wrapper around your SQLite database. And he loved it. It's great to work with. We're not going to be using that tomorrow because we want to show you the low level, how everything works. And then on your own, you could learn Room and other things like that. It's a new thing that Android uses to build that. Anyway, I've already kept you late. Let's go ahead and let you go. Let's click stop there. Thanks for sticking with it. This one was a lot cleaner than last time. If you want, go ahead and provide, I'll throw up a couple of polls here and I'll ping you. I would like to get your feedback on how you felt about doing the challenges and the breakout rooms, how well you thought that worked. I think that would be good. Actually, I'll just throw them in with Polly in the channel so it's easier for you to do that. That's it. I'm clicking the meeting to end. We will see you all. Today's Tuesday, yeah, so we'll see you all tomorrow. Ciao.